In three, two, one, level zero. Bam. Hey, good evening, everyone. It's Mr. Lee. Today is Thursday, April 2nd. I apologize. I think last stream I made like the wrong date. So here we go. Today, if you look on chat, I'll write down the objective. So right now the timestamp looks like it's about the 30 something second. I'll write down today's date, and if you can copy that down, the date is Thursday, April 2nd, 2020. And this is my cat right here, Ayla. Look at that. Awesome. She's, I don't know, maybe the stream's mascot. That'd be kind of cool. So today's objective, if you can also write this down into a line paper, students will be able to solve two-step equations. And this goes back to what we were doing like a month ago. So I believe this should be section 4 of chapter 5. Yeah, I believe this is section 4. So we kind of did a quick little recap of one-step equations. And if you remember on last Tuesday's stream, that we had a ticket out. So right now, look at your problems from before, and if you look in the red ink, these should be your answers right here. Pause it right at the 142 mark, and yeah, get that down. All right, so let's figure out what to do next. For like, I have 107 subscribers, and I know 30 of them are new from this week. For those 30, if you can spread the word and just make sure more and more people from our classes get onto this channel. Again, you can check on the Amphitheater website and go to Amphi Middle School and go to the math staff, and you'll see a link to this stream. Or you can just also spread the word, viral marketing. All right. So two-step equations. Pretty much when we do two-step equations, we're doing PEMDAS backwards. We're doing, please excuse my dear Aunt Sally. We're doing parentheses. So let's see, P, E, M, D, A, and S. So please excuse my dear Aunt Sally, right? That's parentheses, exponents, multiply, divide, adding, and subtracting. And it's kind of funny. Like we haven't talked a lot about exponents, but being a little bit more topical, like for the last month with all what's been going on, if you ever tune on to the news, they keep on talking about flattening the curve. So an exponent means like how much of a copy of a clone of a number there is. So check this out. If I have 3, how many copies of the number 3 did I write down? Well, the number of copies that I wrote down were 3 to the first power. So if I wrote down 3 times 3, how many copies of 3 do I have? 2 copies. So I've got 3 to the second power. And 3 times 3 is what? Is that 6? Nah, it's not 6. 3 times 3 gets me 9. A really common mistake that people do with exponents is they think that this little tiny number means you multiply it by the really big number. And here's one other thing. If I do 3 times 3 times 3, well, I know 3 times 3 is 9, and 9 times 3 gets me 27. So 3 to the third power is what we write down, and 3 to the third power is 27. Now, let me use a different pen. That one's kind of gloppy looking. Ayla, you take care of the pen. Yeah, actually, don't take care of the pen. You're a cat. You can't do that. But let's see here. Let's get back to what we were saying. So I'll rewrite what we have. We have 3 to the first equals 3. 3 to the second equals 3 times 3, which equals 9. and 3 to the third equals 9 times 3, which is 27. Now, if you can write down this, I'll write down 2 to the third power. This big old 2, that's called the base. And this little 3 right here, that's called the exponent. And before we left, I was talking about when we do equations, we're graphing lines. So a lot of times when you have a graph, you're going to get just like a straight O line like that. When you get when we do like constants and when we find things that are proportional, we find like lines. What you've been noticing on the news though is look how big this number got. We started from 3, we went to 9, and we get to 27. When you have an exponent, an exponential function means something's being multiplied by its copies really, really fast. So right here, this is called an exponential function or exponential curve. And on the news, they've talked about flattening that curve. And that's why we're all indoors, quarantined in our house. We're trying to make this curve, we're trying to flatten that out. We're trying to flatten that out into like a line because lines don't go as fast as exponents. I don't know. I thought that was something kind of neat that relates to what we're doing. Like math is all over, right? And sadly, there's a lot of math that's happening right now as we're all quarantined. Not only is it just like the brave doctors and nurses that are in the hospitals helping out, but it's also the mathematicians and scientists who are counting and keeping track of how many people are getting sick, not getting sick, how fast the disease spreads. And they use a lot of math that we're kind of like learning at a beginning level, and they're taking that like an expert level, you know? Getting back to what I was saying earlier. So we have PEMDAS. For us, we've been talking about working PEMDAS backwards. So normally you would go down this list and you do parentheses first, exponents, multiply, divide, add, and subtract. When we do our algebra, we're going from the bottom and working our way to the top. So normally PEMDAS is from you start from P and you end at S. Now with algebra, we start with subtracting and adding, and we end with our parentheses. One thing I wanted to note too was our first example. So let's do example 1. And example 1 is we have 2x plus 3 equals 7. And what we're going to do, of course, is we're going to draw our line through the middle. And we'll do the opposite of left. I'll subtract 3 right here on the right. And the reason I'm doing that is when I read this sentence, it says 2 times x plus 3 equals 7. And because we're doing PEMDAS backwards, I want to start with the adding first because it's simpler to knock off. The 3's are going to go away. And now they're go away because I'm doing the opposite of adding by 3, which is subtract by 3. So I do 7 minus 3, and I get 4. Now I ask myself, who didn't get crossed out? Well, it's 2x. One thing to note is x is a variable. There's no symbol in between the 2 and the x, but there's like an implied little dot equals 2. All right. So I want you guys to try this then. I want you to try 3y plus 4 equals 13. So right now, pause the video, get this down. All right, so draw your line through the middle, and let's go for this answer. We have minus 4, we've got minus 4. The 4's go away, and 13 minus 4, 5, 6, 7, 8, 9, 10, and 12, 13. Well, 13 minus 4 gets me 9. I have 3y right here because he didn't get crossed out. 3 times y. And the opposite of times 3 is divide by 3. Y equals 3. You can whatever what you do on one side, you do to the other side. And the same thing should work out. This is going to be example 2. If I have everything on the right-hand side. So I'm going to have 25 y. Here we go. I have 128 equals 25y plus 3. Again, it's 128 equals 25 times y plus 3. Let's draw a line right through the middle. So I'm going to divide this. Actually, we can't divide this. Derp. We subtract by 3 on the right side, and I subtract by 3 on the left side. 25y is left, and I got 125 on the right. I divide this by 25. I divide this by 25. Y gets crossed out. 25 goes into 125. How many quarters would it take to get me $1.25 or 125 cents? Well, 4 quarters is 100, and then 5 quarters is $1.25. So 25 goes into 5 times. 5 equals y. Today is what, Thursday. I'm gonna cut this a little bit short. I want to make sure that you guys aren't completely overwhelmed with all this stuff. I just want to keep things a little bit better. So 2-step equations, 2 examples. Make sure that you go on to Alex and again try and log in 30 minutes. Last week you're also given a packet, and also you have a paper that's still due. So guys, that's it for today's stream. I'm kind of short for 13 minutes. But anyway, you stay indoors, stay healthy, and I will talk to you guys later. Let's end this with Ayla. What are you doing? What are you doing, you beast? Look at that. Anyway, good night, guys.